All right, welcome. This is the week 12's homework. This is Tuesday, uh, October 22. Okay, number one, the table shows some input and output. This should be output values for a function rule. Which description and equation can be used to find the function? Select all that apply. All right, so we know that, if you watch Monday's homework solution, we should know that the x value is your input. So let me just write that out for you, which is your input, okay? And your y is considered your output. All right, so let's just check this out. So the first one, we have an equation, so we gotta test it out. So we could grab some values. We can grab this, or we can grab, let's grab this. Let's test this out, okay? So we have y is equal to, right here, 2, but what is x? X is 0, so plug in 0 here, right? And minus 2. Y is 2 times 0 is 0, minus 2, so y is equal to negative 2. Oh, that works, right? We think it's this one, but if you also check this, but let's check something else. Let's check this. Okay, watch. You're going to see how it breaks if you check this. All right? So, y is equal to 2, parentheses. The x was your 2. Close it, minus 2. Y is equal to 2 times 2 is 4, minus 2. What is 4 minus 2? It is 2. Does that work? You see? It doesn't, because when your input was 2, your output was 2. So this doesn't work. Oh, sorry. So this one doesn't work. Okay. We could check this one. A lot of people think this one works. All right. So let's see it. Y is equal to 3. Your x here was 0. And it is minus 2. So 0 times 3 is 0, minus 2. Your y does become negative 2, so that works. We could test the orange now. Y is equal to 3, but this time the parentheses is 2. That is your input. And it is what? Minus 2. Y is equal to 3 times 2 is 6, minus 2. Y is equal to 6 minus 2 is 4. So does that work? Your input here is 2, your output here is 4. That works. So this one is a valid answer. There you go. Double the input, then subtract the 5. Okay, I'm going to erase this work, okay, because I need the room. Okay. Okay. All right, let's just erase this. Okay, let's see. I'm just spending a lot of time. Double the input, then subtract 5. Okay, so let me double the input. So the input here was 0. So your x was 0. Okay, that's your input. So your input was 0. If I double the input, I double this, it becomes, if I double it, it becomes 0. Then I subtract 5, it becomes 5. Does that equals negative 2? Nope. So that makes no sense. Triple the input, then subtract 2. Okay, let's see if it works. So x is equal to 0. The input here is what? The input is 0. I triple it, so 0 times 0 times 0, then subtract 2. Does it work? Good. Okay, let's just check another number. Let's check 2. Okay, let's just to make sure it works. Let's just test out different values. So x equals to 2. So the input here was equal to what number? 2. So the input was 2. We triple it, so 2. Double it becomes 4. Then we triple it becomes 8. Then we subtract what? 2. Wait, triple it. So 2. Oh, I think. Wait, hold on. Triple the input. So This is vague. I think it's multiplied by 3. I think it's multiplied by 3. 2 times 3, this becomes 6. Then subtract the 2. Okay, subtract 2 from 6 does get you a 4. So yeah, this one would work. Please be careful. I'm going to treat the triple as multiplying by 3. I'm not going to treat the triple as to the power of 3. Okay? And okay, let's do subtract 2 from twice the input. Okay? So, let's check this one. So, you know what, the blue, the zero is giving us a lot of problem. Let's just check the orange, right? Makes it a little bit easier. Subtract 2 from the input. So you start with 2, that was your input. Subtract 2, that gets you 0. Does that work? Subtract 2 from twice the input. So this is the input, right? This was the input. And what do we want to do? We want to subtract 2 from twice the input. So we got to twice this. So if we twice it, it becomes the number 4. Then we want to what? Subtract 2. That becomes a 2. Does that work? Nope. So this one's wrong. So the only ones that work are the second one, y equals to 3, x minus 2, and this one, triple the input, then subtract 2. Okay, this is the word form of that equation. All right, using the line of graph to write the equation that represents the function, here it goes. Please understand that the equation, this looks like a what? This looks like a line. A line is a what? It's a linear equation. Okay, all lines make up a linear equation, so we can just write it. Y is equal to mx plus b, where the m is equal to the slope, which is delta y, over your delta x, and the b is your y-intercept, which is your starting point. So let's get b first, my starting point. Where does it start? Does it start up here? Nope. Does it start here? Nope. It starts right here. That value is -1. Okay? Because this is the point 0 for your x and -1 for your y. That is why your y-intercept is -1. Next, we want to get delta y. What is delta y? My delta y is my change of y. So let me grab another point really quick. So here, this is the second point, okay? Because it's intersecting right there. So my delta y, let's count. 1, 2, 3. My delta y is -3. Okay, so my delta y is equal to -3. And my delta x, 1. So delta x is just 1. So delta x is equal to 1. So if you want to plug it in your sloped formula, it is what? Delta, your m is equal to -3 divided by 1. So here's my equation. What goes in for m? We plug in the number, -3 over 1. So it's -3 over 1x. What do we plug in for b? We plug in the number 1. So that is my equation. Oh, do we ever write plus negative? No. Just delete that. So this is my equation. Y equals to -3 over 1x minus 1. That is how you write an equation that represents this function, which is a linear equation. All right. Number 3. Is there only 3 questions here? All right, let me double check. Hold on, give me a second. All right, so it actually seems like this is the third one. Yeah, there's only 3 questions here. All right, which one represents a function? Please remember what the rule of a function is. Okay, every input, which is x, has exactly one output, which is y. Okay, so let's go over this. Check it out. If you plug in the 0, what do you get? -2. If you, right, that works. Good. If you plug in a 2, it gets you a 0. That works. You plug in a 3, you get a 1. That works. You plug in a 7, get you 5. That works. So this is a function. Okay. Here, let's do this one. If you plug in a 4, what do you get? -2. Wait, makes no sense. If you plug in a 4, you get a 2. Uh-oh, which one do you get? If you plug in, if y is your input, okay, what is your output? Is your output. What is your output based on this chart? You can't answer it because there are two different y values. So this is not a function. This is bad. There are multiple outputs. There was -2 was an output and 2 was an output. This is bad. Okay? Let's do this one. If you plug in -2, what do you get? -3? Wait. Right here. -2 also gave you a 3. What is the output? What is the output? So, if, again, I'm going to just grab this, bring it over here. I'm going to grab this, but this time I'm going to change the number 4 to the number -2 and ask this very simple question. If you have -2 as your input, what is your output? You don't know. You don't know. It can either be -3 or 3. This is why this is not a function. Okay? If you plug in a -3, the last one, if you plug in a -3, what do you get? -9 works perfectly fine. Plug in a -1, you get -3, perfectly fine. Plug in a 0, you get a 0. You plug in a 5, you get 15. Perfectly works. So it seems like this one is a function and this one is a function. Everything else is not a function. Why? It breaks this rule. Okay, so there you go. Those are all your solutions for Tuesday, October 22. This is week 12 homework.